Alright, this is our last video for practice or the unit review for Unit 2, the even solutions. This is 54, and it wants us to graph this system of inequalities. This one's already solved for y, so that's good to go. This one over here, I'm going to go ahead and solve for y, put it into a y equals mx plus b equivalent. Plus 1, I'll divide by negative 1 to get that y by itself. And when I do this, I have to flip the inequality sign. So I guess I can kind of squeeze it in right here. So this one has a y-intercept of 0, and so it's down 2 over 1. So that's right there. That's a solid line. And that says the y's are greater than, so I'm going to shade basically up here above it. Okay, just going to do it kind of lightly. And then over here it has a y-intercept of negative 1, and it goes up 2 over 1. It's right there. Right there and right there, and that's a solid line also. Okay, y-intercept of negative 1, up 2. And this is where the y's are less than it, so that would be over here. So basically I'm going to shade in that region right there. 56. I'm looking at question 56, same thing. They got it already set up for me, so it shouldn't be too much work. Okay. And let's just jump in and graph it here. I'm going to do the two vertical and horizontal lines first. So I'll do y is less than or equal to 3. So 1, 2, 3. There's y equals 3, and that's a solid horizontal line. And the y's are less than, so I would shade below. Just kind of doing that lightly here. Go to y, or x equals negative 1, which is right there, and this is a solid vertical line. That's where they're greater, so that would be in this region over here. So now I know I'm kind of dealing in this region. And then I go to y equals negative 3 for this one. And I go up 2 over 1. That's about right there. And this is also a solid line also. So I've got to continue that line down. And this is where the y's are greater, so my answer is everything in here. That's where the y's are greater. And last question, number 58. It's a 3-variable system. So we get negative 3x plus y minus z equals negative 2. 2x minus y minus 2z equals negative 12. And 4x plus 2y plus z equals 1. And I got to pick a variable to get rid of, and I'm going to get rid of y. Get rid of y. Like I see these two here. So that's equation 1, that's equation 2, and that's equation 3. I usually always circle those so I don't get this, it doesn't turn into a 22 or a 34 or something. So I'm going to take equations 1 and 2, and I'm going to go ahead and get rid of the y. Okay. Now remember, this process has to be done twice, so those go away, and I get negative x minus 3z equals negative 14. Okay, and I'm going to kind of stop there. I got one equation. Now I got to do that again. I'm going to go ahead and take equations 2 and 3 this time, though. And I'm going to take equation 2, and I'm going to multiply it by positive 2 so I can get a negative and a positive 2y. So I'm looking at 4x minus 2y minus 4z equals negative 24, all over 4x plus 2y plus z equals 1. And in this case, these don't go away. Those are positives. Be careful. Minus 3z equals negative 23. So now I have two equations with the same variables. I'm going to go ahead and line these up. You can see here, I'm going to multiply this by negative 1 because I want to get a negative 3 and a positive 3. So this equation is going to turn into x plus 3z equals 14. So I multiplied that by a positive 1, bringing this underneath, equals negative 23. And I'm going to get that to go away, and I'm looking at 9 equals negative 9. Divide by 9, and x equals 1. Right? So I got x. I'm going to find z. I'm going to plug it into this equation up here. So I'm going to say negative 1 minus 3 times z equals negative 14. Add 1 to both sides. Negative 3z equals negative 13. Hopefully this comes, this is, I didn't think this would be a fraction, but let me just double check here. Put in the 1, oh, that's why. That should have been a negative 1. That should be a positive 1. That should be a minus 1. And this should be 15 right here, negative. Caught that error. And this is negative 5. Okay, sorry, positive 5, because I divided by negative 3. So there's my x, there's my z. Go back to the original equations up top here and pick one out. And I need to get y. So I'm going to go with equation 1. I'm going to say negative 3 times negative 1 plus y minus positive 5 equals negative 2. I'm going to get 3 plus y minus 5 equals negative 2. Y minus 2 equals negative 2. And then y equals 0 when I add 2 to both sides. So my actual answer is negative 1, 0, 5. And be careful. As you see, I missed this negative here. That's a very, very common issue. Something small like that.